So good evening. My name is Winston Karanja. I'm a developer and also chief AI strategist at Lambda Softwares Limited. Today, I'm going to take you through AI workflows and their integration in our current systems. This presentation is going to guide us through the enterprise architects and the AI engineers, and the technical product is going to guide architects, engineers, and product managers through the critical transition of AI from isolated experiments to robust and production-ready systems. We are going to explore how advanced frameworks such as langchain and machine context protocols can streamline AI workflows and enhance system predictability and ensure seamless integration within the enterprise ecosystems. So let us take a close look at the evolution of AI workflows. Why do AI workflows matter? Traditional AI experiments often remained siloed, failing to integrate into production-grade systems. For example, you might find that the data that has been picked by fashion designers to train an image classification model, the data has been fine-tuned towards a certain fashion group, whereby when you expose the model into the outside world where there is so much uncertainty, you find that the LLM starts becoming noisy and the output starts becoming variable. And that is one thing that you are trying to curb. So, introduction into LLMs. Large language models here offer unprecedented capabilities in reasoning, text processing, and also language processing and natural language processing, that is NLP. However, LLMs are usually prone to hallucination and also the inference cost that is incurred during, inferring the LLM each and every time in your workflow, necessitate a structured approach for reliable deployment in a production-grade environment. AI agents is basically an LLM combined with either a tool plus a prompt or a prompt template. And this, a combination of the three key things that form an agent here help in automating complex tasks from customer support to code generation to transforming operational efficiency. So we're going to start with a foundational framework, which is langchain ecosystem. Langchain here is one of the building blocks in helping build modular components like chains, retrievers, and also memory for constructing complex LLM applications. It abstracts away much of the complexity, allowing developers to focus on the application logic itself. Chains are a sequence of calls. For example, an example of a chain can be combined with an LLM, a vector store retriever, and a prompt template. An LLM, vector store retriever, and a prompt template together combined forms a single chain in langchain. Then a retriever is, for example, a vector store or a database whereby one can fetch relevant data or LLM can fetch relevant data. And memory in this case is stateful interactions. Langchain here in this case uses a class known as messages state to help with stateful interactions, offloading the work of the developer for having to, sit down and write the logic to, ensure that the chat history is passed to the LLM for the previous interactions that the user had with the AI. So next, there is langgraph. Langgraph here is a tool that helps us develop stateful agent workflows. Langgraph extends langchain by enabling stateful and cyclical agent workflows using a graph-based approach. We are going to learn about that soon. And this allows for more dynamic and predictable multi-step decision-making, which is crucial for advanced AI agents. Then there's langsmith. Here, langsmith helps us with observability and debugging. Langsmith usually offers comprehensive tools for debugging and testing and evaluating LLM applications. It provides visibility into every step of an AI workflow, ensuring reliability and performance. So I'm going to now share you something small about langchain, some small basics in code. So you're going to start with the simplest graph of them all. A graph is basically formed of, comprised of three main things: a start node, an end node, which is basically mandatory in this case, and other nodes that are in the center of the graph that build the logic of your graph. There are two different types of nodes. There are regular nodes and there are conditional edges, and you're going to learn about them slowly. Let's scroll a little bit. So basically, when creating a graph, the first thing you need to do is define the state. The state schema here serves as the input schema for all nodes and edges in the graph. This, in our case here, langchain usually accepts typedict, which is a class from Python's typing as a module, the typing module as our schema here, and it provides type hints for the keys. Another class that we can use here to pass in the state is usually the pydantic base model. And talk about the nodes. The nodes here are just Python functions, basically. And here, the first positional argument is the state, which has been defined above. Because the state is a typedict here, with the schema that is defined, each node here can access the key, the graph state, with the state graph state. And each node returns a new value of the state key graph state. Let's go to edges. So edges here basically just connect one node to the other. Normal edges are used if you want to always go from node 1 to node 2. Conditional edges are used if you want to go to node 1 or node 2. I hope you can understand the difference. Then graph construction. Basically, we build our graph from the components that have been defined above. The state graph class is the graph class that we can use in building the graph. First, we initialize state graph with the state class as defined. Then we add our nodes and edges. Then we use the start node, which is a special node that sends user input to the graph to indicate where the graph starts. And the end node is a special node which represents the termination of a graph. And finally, you compile the graph to perform a few basic checks of the graph structure. Basically, here, as you can see, back a little bit to the code. So you can see there we have imported IPython just to show the image of the graph that will be built. Then from langgraph, which is the package here you are using, we are importing state graph, which is the class that passes the state, and also the start and end nodes. Then this is how you just build a graph. Initiate a variable called builder and say state graph and pass in the state, sorry. Then you add all your nodes. After adding the nodes, you start building the logic by using the method add edges or add conditional edges. So as you can see in the edges, the first edge linked start to the first node. The conditional edge linked the first node to a function decide mood, and another edge linked node 2 to end. As you can see, if you scroll down a little bit to the image, the regular edge led us direct to node 1, but the conditional edge was taking us to either node 2 or node 3. That's the difference between a regular edge and a conditional edge. Then next, we go to graph invocation. So after compiling the graph, you simply invoke it using the user input. Here, we just ensure that the user input follows the class that has been defined above. In our case, it was just a simple typedict. So passing in graph state and saying, hi, this is Lance. Then the invoke node runs the entire graph and returns a result. So basically, that is just a quick overview about langchain and langgraph. We are going to talk about langsmith shortly. You can now stop presenting so that you can continue. So Let's go to advanced AI workflow patterns. So we have multiple advanced workflow patterns that are being used. We are going to look at a basic concept, or rather two basic concepts that are linked to langchain, langgraph, and by extension, using langsmith to help us, monitor our graphs. So we are going to start with retrieval augmented generation. Retrieval augmented generation is basically injecting enterprise-specific context into LLM responses. For example, if you try ask ChatGPT a basic question about the statistics of Erling Haaland, you'll find that ChatGPT either uses the in-base memory that that was used to train the LLM, or opts to go to the search tool to go and search in the web about the statistics of Haaland. RAG in this case is whereby you compile all the statistics that exist about the Premier League, for example, let's say, create a sort of vector store, then inject that context into the LLM injecting the context into the LLM plus a prompt to ensure that the LLM responses become more knowledgeable, overcoming knowledge limitations. A typical architecture here usually involves querying a database to retrieve relevant documents, which then augment the LLM's generation. This powers accurate policy, question and answer systems, or intelligent application companions. So for example here, as you can see in the image, you'll see a question or a user query will be routed into an indexing section here, whereby the vector store is queried using, they call them vectors. The query is converted into vectors. The vectors are used to query the vector store. After that, retrieval of vectors are done and returned back to the LLM. After the vector store has been retrieved, the vectors are converted back into the specific documents that were vectorized beforehand. Then from there, the context now that is retrieved is now passed into the LLM plus a prompt, making the LLM's answer more knowledgeable. Then you're also going to talk about graph-based agents. These agents here utilize a graph-based execution for sophisticated multi-step decision-making. For example, consider an IT troubleshooting assistant that navigates diagnostic steps based on a user input and dynamically adapting its approach to resolve issues. So, as you can see in this image here, this is the agent or node. It decides to call a function. Then it goes to a conditional edge. Should it retrieve? Yes. It continues and retrieves the documents. Then from there, it checks the relevance of the documents. Are the documents retrieved relevant? If yes, then the LLM is given the documents and the answer is generated. If not, if the LLM doesn't need to retrieve, you can just end the graph there. And also, if the relevance of the documents retrieved are not relevant enough, you can re-execute the function and start the process all over again. So that's just a slight tidbit about complex agents. So I'm going to show you something small on Lang Studio now. So as you can see, this is the tracing and observability and monitoring platform that I was talking about, which is langsmith. So the goal of langsmith here is to help us trace our graphs. For example, here you can see that I had two different graphs that I had created some while ago. If you can click, for example, let's start with a more basic one, like this one. So this is actually, as you can see, this was done some time back. This was a system that was automating a small process. We can go into it step by step, as I explained. So the start node routed into the weather node. The work of the weather node here was to collect weather data of a specific location based on the latitude and longitude that were given in by the user. After that, if the image that was uploaded by the user, that is, okay, the work of this graph here was to use an image that has been uploaded into the system. You upload an image, either in form of a PNG, JPEG, or even TIFF images for geospatial engineers. Then the image is either tagged by a geolocator, or the user manually writes in the coordinates of the image where the picture was, of the location of where the image was taken. Then from there, the weather node uses the location coordinates to pick up the specific weather data of that location. Then from there, depending with the image format, if the image format was a TIFF file, TIFF files usually have one special capability whereby it has extra bands more than the regular red, blue, and green that may aid in calculation of more complex vegetation indices such as normalized difference vegetation index and such. So it will either be routed in that pipeline or another model here, which is called YOLO, you only live once, by Utralytics, to do pest classification. So if an image, you'll find if an image had a pest, the YOLO model will detect it, and it will tell you the exact kind of pest that has been detected. Then from there, all this data was being aggregated here by a node I called Maui. I think this is an LLM. I plugged in Chatanthropic for this case here. So Chatanthropic had a prompt template. Then it had context-specific data, which is data from the weather node and DVI pipeline and the YOLO analysis model combined, and also a prompt template that would aid it give a more proactive recommendation to a farmer about how they would handle their farm. So the goal of this whole graph here was to aid farmers who had large scale farms. You can just fly a drone, take pictures, like 5-10 pictures, and then you run them through the graph, and you'll either know if you need to irrigate, if you need to apply pesticides or something. I can show you another more complex graph here. This is a more complex graph. As you can see, there is, of course, a start node and an end node. But here, there is one master node, more of a master agent here that behaves as a router and at the same time as a chief oracle, a know-it-all. Then from there, we have multiple other nodes that are, service dependent. That is, it's a specific feature you want to implement. It's a node on its own. It makes it easier to scale and add more nodes and more nodes. So you can see here, you can also have a node as a graph. Instead of having just a graph, you can have a node as a graph too, here, whereby the master agent can extend into another subgraph, I think. Okay. As you can see, the master node or the master agent here routed into the other subgraph. And the work of this subgraph was to do report writing. So as you can see, here are some of the interactions I had with the graph. So I asked just a simple question because I had changed the the API key and some of the code. So I asked it, am I using Anthropic or OpenAI? And it said an AI assistant with Anthropic's technology. Then I invoked again. I asked it, state precisely the details of any case law you can access from 2024. The master agent here called the retrieve node, where the vector store is. The retrieve node, as you can see, it returned a success message. And from there, based on the retrieved documents, the AI answered that this is what had been retrieved. This is just one of the simple ways you can just apply retrieval augmented technology, retrieval augmented generation using graphs. So we'll go to next and more. We're going to go to more advanced concepts now. One of the more advanced concepts here are Model Context Protocol, which is MCP. MCP provides a standardized method for LLMs to access tools and resources, promoting consistency and interoperability across enterprise systems. This means that your LLMs can reliably interact with diverse backend services. So in MCP, there are two sides here. There is the MCP server and then the MCP client. So the MCP server is the one that hosts the components. Example of components here are tools, resources, or prompts. So organization can host all their internal resources and tools as MCP servers, transforming complex systems into easily consumable endpoints for LLMs. For example, a database can become an MCP server or an MCP tool to be specific, allowing LLMs to query and retrieve data directly and securely. An MCP client function here is just to consume services. LLM workflows here can seamlessly consume these MCP servers by enabling dynamic interactions with enterprise systems. An LLM can connect to an ERP system via an MCP client to retrieve inventory data or trigger a purchase order. This unified approach eliminates all ad hoc integrations and reduces also development time and enhances the security posture of AI application. As you can see, the MCP servers can exist on their own. The MCP client, which is the host, exists on their own. Communication between MCP client and MCP server is an MCP protocol, which right now they use HTTP2. And communication between an MCP server to a database might be, for example, transmission control protocol. An MCP server and a file management system, you can use NFS. If you want an MCP connection, an MCP server to connect to the internet, you're of course going to use HTTPS. So LLM workflows with MCP features. So I've talked about components. Components easily expose internal APIs and functions to LLMs using simple decorators like at mcp.tool, at mcp.resource, or at mcp.prompt. For instance, you can expose an internal HR API for an LLM to query an employee information securely. Then, MCP also offers comprehensive logging through the context class. MCP includes robust logging capabilities which provide detailed insights into every interaction between LLMs and a tool or a resource or a prompt that exists within an MCP server. This is vital for debugging, auditing, and compliance. Then there's something called user elicitation and structured extraction. Elicitation here enhances the LLM's ability to extract structured information from a structured text. This feature is crucial for automating data entry, populating databases, or understanding complex user queries in a structured format. This is a scenario whereby, for example, a user inputs the wrong values. So instead of just returning back an error and ending the graph or ending the whole flow, you request the user, you first let them know that you've input the wrong thing, then request them to input the correct thing and help them, guide them step by step on what to input. Then there's context management and sampling. MCP also provides sophisticated context management, ensuring that LLMs maintain relevant conversation history. Advanced sampling strategies here allow for controlled exploration of tool outputs, which optimize the performance and cost. So sampling, in this case, instead of querying a tool, then wait for the tool to return the results, then passing the results back into the LLM in a raw manner. MCP here allows you, just after the tool has finished executing, instead of returning the result, first, you allow the LLM to sample that result. So in this case, since MCP helps us in structuring unstructured data, if the data was unstructured in some way in that async, async loop, async flow, MCP helps you structure that data, structure the unstructured data back into structured data, then sample that and give a more accurate and more reproducible output. Then real-time progress reporting. MCPs also integrate real-time progress reporting to provide feedback on long-running LLM-driven tasks, hence improving user experience and transparency in complex workflows. In this case here, for example, if you are using an MCP at mcp.tool, which is a tool that, let's say, for example, goes to retrieve from a vector store, and the vector store is so large, so the time that it takes to query might be what? Let's say, for example, 7 to 10 seconds. So instead of the user waiting for 7 to 10 seconds and you're rendering nothing to the screen, in the middle of, let's say specific steps, after this step, you say context.report progress, 25%. Then after 2 other steps, context.report progress, 50%. So instead of the user waiting for the whole 10 seconds for an output, the user first gets, okay, I'm 25% done, 50% done, 75% done, then now the user get back the answer, which helps in building a better user experience, especially in a very complex application. So these features collectively usually enable enterprises to build highly capable, transparent, and scalable LLM applications, especially compared to just using regular langchain, langgraph, and langsmith. So MCP also usually offers seamless integration and orchestration, especially with the SDKs from OpenAI, Gemini, and Claude Code. So with OpenAI, if you have worked with OpenAI, you've heard of chat.completions.create. So chat.completions.create don't support MCP tools. MCP tools here by OpenAI are usually supported via responses API, which is chat.responses.create. Then under the tools section, you pass in tools, you pass in the whole MCP server as tools. Then the LLM will be able to see the whole MCP server on the client side. This allows enterprises to leverage their preferred providers while maintaining consistent tool access and security policies. You can also mix concepts for complex workflows. So the true power in AI integration lies in combining all these frameworks. You orchestrate complex processes using langchain and langgraph, for example, which helps you, wrap complex logic into bite-sized step-by-step problems. Then after that, you can wrap the whole graph as one function. That is, you can wrap the invoke, let's say the place where you invoke, you can wrap it as a function. Then from there, that function expose it as a tool. So in this case, instead of just having langchain and langgraph integrations, you've now used langchain and langgraph integrations plus MCP. The MCP here comes in as the tool which calls the whole graph. And that is how you can build more complex systems. For example, you can generate a marketing plan that is using a langchain powered LLM. Then from there, you can validate data from the database using an MCP resource. Then you can trigger a post in Instagram using an MCP tool. Then AI integration is not just in backend and complex logic. AI integration is also in user experience and user interface. So fundamentally, you are reshaping user interfaces and experiences, expecting more of conversational user interfaces. For example, elicitation that I was talking about. Elicitation is whereby the LLM queries the user back that you gave the wrong input, now give back the correct input. You can also use contextual sidebars. You can use dynamic breakpoints and also human-in-the-loop interventions for critical decisions. And also, let alone cron jobs. You can build AI agents and schedule cron jobs that run after every 15 minutes or every 6 hours that update important key aspects of the cards that you have rendered in the dashboard. For example, you have a component that calculates, let's say, the total amount that the person has earned this month. So instead of calculating using a regular function, you can have an AI agent run every 6 hours, look at all the data, analyze, then update. Then after that, it sleeps, it batches all the data again, then it runs. So designing AI workflows, the principles that here we prioritize is 1, clarity, especially in your prompts. Again, provide clear fallback paths for unexpected AI behavior. The problem with LLMs is that the output of an LLM is not reproducible. Even though we are using these frameworks to try and control the LLM, sometimes there are specific edge cases where the LLM does its own thing, it hallucinates and does its own thing. So in such cases, you need to provide clear fallback paths, and also you can orchestrate a fallback path where it reinitiates the loop again, so that you can try and get a correct output this time. Then also always keep the human in the loop. We need to avoid an opaque black box automation whereby the LLM decides everything, because transparency builds trust and enables effective collaborations. So my thoughts are, if you are integrating AI in your system, first, start simple. 2, decide your workflows that you're going to use, then expand them. Then 3, scale with MCP. AI integration is not about replacing the systems, but rather extending them in an LLM-friendly manner. Thank you so much. Yeah, if you have any questions, I can. Yes. Yes.
The platform you shared, it's called langgraph or langchain. The platform you build the agency, is it do you pay to build on each or is there?
Okay, so I've named the langs. I've named 3 langs: langgraph, langchain, and langsmith. Langgraph and langchain are open source. You can build your workflows at 0 cost. But now, if you want to monitor whatever you've built using langsmith, langsmith is paid. Understood?
Can you give examples of enterprise level AI LLM implementation?
Okay, sure.
I think most of us just know like ChatGPT.
Okay. Let me show you an example here. So let me confirm if Docker is just running a moment. Yeah, I think it should be fine. So on one side, I have server side, and the other side, I have a client side. The server side is my MCP server. This is just a basic server right now. It consists of where are the tools? Yeah, it consists of two major categories of tools. One of them fetches for example here, bucket.py. These are S3 bucket operations. If you've worked with Amazon S3, so the regular CRUD of operations, put object, get object, delete, and everything. As you can see, each function, I've exposed it to the MCP as we're using the decorator at mcp.tool. Then also, I have others for the vector store. In this case, I'm using Pinecone. So there's still basic CRUD operations. For example, this query vectors, this query multiple namespaces, these abstract vectors, these delete vectors. Again, each tool has been decorated using the mcp.tool. I was talking about user elicitation, about reporting progress. All that is done via the class context, as you can see. And for example here, if you can see abstract vectors, we have context.report progress, that is progress reporting. We have context.info, this is logging. We have another one, context.error to raise errors. If we look at query vectors, same thing, report progress. So the work of context here is just to extend and give the extra features to the user, like logging, elicitation, reporting progress, such stuff. So after this, all these tools were exposed to the main server here. This is the central server instance. I imported the other two servers in this point here. So from there, when you run the server, so as you can see, my server is now running here on Docker. So in the client side, I can just have simple client.py here. I can ask it hopefully. Yeah, no errors so far. And here we go. So I just asked it a simple question. Hello, what tools do you have access to? After connecting it to the MCP server, it replied back, hello, I have access to the tools related to vector storage and S3 bucket management. And here are some of the capabilities, which are the exact tools which I had on my server side. This one, and this one. So that is how you start, implementing AI and tools and, having AI workflows. Any other question?
So I know this is more like infra level. Are you open to coming and doing a session like video and stuff like n8n?
N8n. Okay, I can come to do some N8.
Or is that boring stuff?
Yeah, kind of.
Just go and leave it there.
No, I can come help out. I'm always open to help out. Yeah.
For me, I can say that it's a little bit complex.
Mhm.
I appreciate maybe another session where we work on a project. We start with a to-do list, as usual,
Okay.
and then we work on building complexity. As complexity grows, I think that should be more beneficial to the rest of the community in understanding like LLMs, MCP, and how they interconnect.
No problem. We can have another session where we tackle low-code applications like N8 instead of high-level langgraph and langchain operations, and also MCPs.
Awesome. So for me, I'd like to see how this also integrates with Web3, blockchain, create agents around that, MCPs around that.
Yeah, it is possible. Okay, I'm not really good in the Web3 environment, so maybe I can ask a question back. What languages do you guys use?
So it's Rust, Solidity.
Okay. I know with Rust you can create a gRPC connection. Can you do that with Solidity too?
No, not sure.
Okay. I can give an example. TypeScript, yeah, it's possible. I'm also connecting this MCP server with Golang using gRPC. So Golang is also possible. The only thing is that the communication will not be based on the basic HTTP that we are using. You are going to like create a gRPC connection between, let's say, the Rust and now the MCP server. Then after that, after creating that gRPC connection, the functions that were written in Rust that now are going to be our tools, in this case, are going to be converted back in a Python manner. Then using that gRPC connection, when it calls the Python equivalent function, it goes back and calls the Rust function. So that's how it works. So it is possible actually to connect using Web3.
Thank you, Winston. I think that's all for the questions. I say thank you on behalf of the community. It's the first session, true session we have this. Very helpful. I can see someone in the on Zoom asking questions.
Okay.
Go to the chat.
All right. Moment. Is MCP tech the one used to make project or technical documentation easily queryable by LLMs? Yes. Actually, the MCP server solved our problems about tools. For example, if you see my client here, the server is the one that is taking all the load about the tools. So on my client side, assume the others. I'm only running client.py. Oh, sorry. We good? Okay. So the server side here carried all the bulk about the tools and their logic. Some things. Okay, thank you guys.
Thank you so much.
Yeah, I hope you're going to have another session. You let me know the day.